Okay, right now we're going to work through the balancing problems on page 20 in the unit packet. So again, our goal here is to identify the type of reaction and then to make sure that the atoms on the reactant side, or the left side of the arrow, are the same exact number as the atoms on the right side, or the product side of the arrow. So this first problem, I think this one doesn't look like anything we've seen before really, so I would say this is not a type that we've learned already. Now I'm going to start with the bromines here and say that since there are two bromines on the left, I would need two bromines on the right. Now I have two hydrogens on the left. 2 plus 2 hydrogens on the right mean I would need a 2 right here. And then I have 2 plus 2, 4 oxygen atoms on the left, 4 oxygen atoms on the right. So I think this equation is now balanced. Moving on to number 2. I have 1 calcium on the left, 1 calcium on the right. So I think that's balanced for now. I have 2 oxygens on the left, 2 oxygens on the right, and 2 hydrogens on the left, 2 hydrogens on the right. I think this one just gets a check mark. It's already balanced with ratios of 1, 1, and 1. And also, since these are forming one product, I would say this is a synthesis reaction. Problem 3. We're also only forming one product, so I would say this is also a synthesis reaction. Now on the left, we have 2 phosphorus atoms. On the right, we have 2 phosphorus atoms. That's good for now. On the left side, we have 6 oxygen atoms. On the right, we have 8. I'm going to hold off on that for 1 second until I take care of the bariums now, because oxygen is found in 2 places. I now have 1 barium on the left and 3 on the right, so I'm going to go ahead and add a 3 there. And now we notice that also took care of the oxygens. I have 5 oxygens plus 3 oxygens is 8 on the reactant side. 2 times 4 is 8 on the product side. This equation is now balanced. Reaction 3. This looks like a decomposition reaction because I have 1 reactant. In this reaction, I have 1 potassium on the left, 1 potassium on the right. That's good for now. 1 chlorine on the left, 1 chlorine on the right. That's good for now. 3 oxygen atoms on the left, 2 oxygen atoms on the right. The only way to balance out a 3 and 2 is to make the common number 6. So 2 times 3 would be 6 oxygen atoms on the left. 3 times 2 is 6 oxygen atoms on the right. And now because I multiplied the KClO3 by 2, I need 2 KCl's on the right. And now we're balanced. Problem 4. It looks like we have a compound reacting with a compound, and the Na is switching with the hydrogen here, so that would be a double replacement. Starting with the sodium, I have 1 sodium on the left, 2 on the right, so I need a 2 right here. I now have 2 H's plus 2 H's is 4 H's on the left, so I need to have 4 H's on the right. And now we would have 2 oxygens, 2 oxygens, and I usually like to count the polyatomic ions as 1. And I would say we have 1 sulfate on the left, 1 sulfate on the right. So now we are balanced. For question 5, this looks like a single replacement reaction because I have an element switching places with another element in a compound. Now I have 1 aluminum on the left, 1 aluminum on the right. That's okay for now. I have 1 hydrogen on the left, 2 hydrogens on the right. I'm going to go ahead and put a 2 here for now, although I might need to change it. Okay, now I look at the aluminum chloride and notice that I have 2 Cl's on the left and 3 Cl's on the right. I'm going to go ahead and make this a 6 and this a 2. I now have 6 chlorines on the left, 6 chlorines on the right. That means I have to have 2 aluminums on the left and 6 hydrogens on the right. So we now have a 2 to 6 to 2 to 3 ratio. For problem 6, this looks like a synthesis again because I'm forming one product. I have 4 phosphorus atoms on the left. I only have 1 on the right. I'm going to go ahead and make that a 4 for now. And 4 times 3 would be 12 hydrogens on the right. So 6 times 2 would be 12 hydrogens on the left. For problem 7, Again, it looks like I have the iron in a compound switching places with the sodium in a different compound, so that's going to be a double replacement. I have one iron atom on the left and two on the right, so I'm going to fix that. I now have 6 chlorine atoms on the left, the 2 times 3, so I need 6 chlorine atoms on the right. And then I have 6 sodium atoms on the right, so I need 3 times 2 is 6 sodium atoms on the left. And you'll notice when you have 4 atoms in a reaction, the 4th atom is usually going to be balanced after you've done the 3rd. So we notice that we already have 3 sulfurs on both sides. So that one's taken care of. Problem 8. It looks like a synthesis again because I'm forming one product from 2 smaller components. Now I have 1 arsenic atom on the left, 1 arsenic atom on the right. That's okay for now. 2 chlorines on the left and 5 chlorines on the right. The most common number between a 2 and 5 would probably be 10. So 5 times 2 would equal 10 on the left, and 2 times 5 would equal 10 on the right. And now I have 2 arsenics on the right, so I need 2 arsenics on the left. Problem 9. This again looks like a single replacement, a little tricky to identify maybe, but we have a compound reacting with an element. And it looks like the H is switching places with the Au, the hydrogen switching places with the gold. So in this reaction, I have 2 gold atoms on the left. I'm going to start out by writing 2 gold atoms on the right. I have 3 sulfur atoms on the left. I have 1 on the right, so I'm going to go ahead and put a 3 here for now. And then 3 times 2 is 6 hydrogen atoms on the right. 3 times 2 would be 6 hydrogen atoms on the left. So now we're balanced. Problem 10, AlOH3 plus HCl. Again, we have a compound reacting with a compound. That's a good example of a double replacement reaction. 1 aluminum atom on the left, 1 aluminum atom on the right. That's okay for now. I usually like to save O's and H's for the end if I see them in multiple places. So I'm going to move on to the chlorine for a moment here. So I have 3 chlorines on the right, so I'm going to want to have 3 on the left. And now if we look at the oxygens, since I have 3 plus 3 is 6 oxygens on the left, I'm going to want to have 3 times 2 is 6 oxygens on the right. For problem 11, an element reacting with a compound again, the hydrogen is switching places with the iron. This is a single replacement. Now I have 2 hydrogens on the left, 2 hydrogens on the right. That's okay for now. I have 3 irons on the left, 1 on the right. I'm going to fix that. I have 4 oxygens on the left. I need 4 on the right. And now I have 8 hydrogens on the right, so I need 4 times 2 is 8 hydrogens on the left. For number 12, this looks like a an unknown type for now, so I'm going to leave the type not identified. In this problem, maybe we could call it a single replacement because the sodium is combining with this and kicking out the silicone. So in this problem, we have 2 sodiums on the left plus this one over here. Now again, since I see the sodium in 2 spots, I'm going to leave that one alone for 1 second. 1 silicone on the left, 1 silicone on the right. 6 fluorines on the left. We need 6 fluorines on the right. We now have 6 sodiums on the right, so we have 1, 2, plus another 4 would be 6 sodiums on the left. And then again, our silicone is still balanced out. For question 13, C something plus O2. This looks like a combustion reaction to me. Again, the strategy for solving combustion reactions is to balance the carbon first, then the hydrogen, then the oxygen. I call this that Cho method of balancing combustion reactions. So let's balance the carbon first. 5 carbons on the left, 5 carbons on the right. 12 hydrogens on the left, 6 times 2 would be 12 hydrogens on the right. We now have 5 times 2 is 10, plus another 6 would be 16 oxygens on the right. 8 times 2 is 16 on the left. Problem 14 also looks like a combustion reaction because we have C something plus O2. Again, let's follow that Cho method of balancing combustion reactions where we balance carbons, then hydrogens, then oxygens. We notice that we have 6 carbons on the left side of the equation. We need 6 carbons on the right. We have 8 hydrogens on the left. 4 times 2 is 8 on the right. Now we have 6 times 2 is 12, plus another 4 is 16 hydrogens on the right side. And we have to take into account these 6 oxygens right now. So another 5 would take into account these 16 oxygens. So we have 6 plus 10 is 16 on the left. 12 plus 4 is 16 on the right. Problem 15. This looks like, since we have 3 products, again, maybe a none of the above would be the choice. It's none of the reactions we've really discussed. 1 sodium on the left, 1 sodium on the right, 1 chlorine on the left, 2 chlorines on the right. We need to have 2 here. Now since I changed the Na, I'm going to go ahead and make sure we have 2 Nas on the right. I now have 2 hydrogens on the left. 2 plus 2 is 4 hydrogens on the right, so we need a 2 here. And then again, that last element, oxygen, it's going to work out. We have 2 oxygens on the left, 2 oxygens on the right. We're all balanced. Problem 16. It looks like we have a hydrogen switching places with the phosphorus, kind of. So I'd probably say it's a compound plus a compound, most like a double replacement here. 1 phosphorus on the left, 1 phosphorus on the right, 3 chlorines on the left, we need 3 chlorines on the right, 1 nitrogen on the left, we have 3 nitrogens on the right. We now have 9 hydrogens on the left, and 3 times 2 is 6, plus another 3 is 9 hydrogens on the right. 17. It looks like we have an element reacting with a compound, and the hydrogen is switching places with the cobalts. This looks like a single replacement again. 2 cobalts on the left. Let's add 2 for now on the right. 3 sulfurs on the left. 3 sulfurs on the right. And we have 3 times 2 is 6 hydrogens on the right. 3 times 2 is 6 hydrogens on the left. Okay, the last problem. We have two reactants forming 1 product, so I think this again is a synthesis reaction. We have 1 sulfur on the left, 1 sulfur on the right, 4 oxygens on the left, and 3 oxygens on the right. Now this one gets a little tricky, so what I always like to do when I have an even number on one side and an odd number on the other is do what it takes to get rid of that odd number. So I would say 2 of these would turn this into a 6. Now we have 2 sulfurs, so I need 2 sulfurs here. And now we see 2 times 2 is 4, plus 2 is 6, and 2 times 3 is 6. So now we're balanced.